Hello everybody, I'm Kaleb Hecksher. This is a little bit about my work that I've done here at the museum. So, just for some background, I am an avid mineral collector. I've been collecting minerals for about 2 years. I love crystals. I've been fascinated with crystals since I was a little kid. And then I kind of took a break. And let's stay up there for a second. Yeah, I'll let you know when I'm good. So, I went and played volleyball for college. I studied accounting, which is a little bit different than what I'm doing right now. And then I was like, you know what? This isn't what I want to do. And I was like, let's go find some crystals. And now I'm super into crystals, and that's what led me here. I'm also a musician. I've been playing some music up here in Bethel. Here's a picture of me playing with some of my friends. And here's me digging on my university campus. I found a big amethyst crystal, 11 feet underground. So that's a little bit about me. And here's a picture of my collection that I've been working on at home for the past 2 years. So all of these I found myself back home in Pennsylvania. I've put this together in my room. I have a nice little shelf for that. So yeah, that's a little bit about myself. So if we continue, why Maine Mineral Gem Museum? So I was looking for a nice internship that involved crystals, and specifically pegmatite, because pegmatite is what has the coolest crystals. And I decided this is the best place for me. I put in an application and I got a call. I got the Bedell internship, which is really exciting for me. It involves pegmatite research, finding some cool crystals, and a lot of other things that I'll talk about later. So, my goals for the summer coming in. I wanted to learn a little bit about mineral formation, like why they form, how they form, and how I can use that to find new minerals. Along with pegmatite formation. I think pegmatite's really fascinating. And also, I want to learn about being a scientist. I want to be independently thinking about a lot of scientific processes and eventually become a professor. That's my end goal. So yeah, got some cool stuff going on. All right. So my first 6 weeks involved working with Al Falster. I did some research on the Emmons Pegmatite. So my mission was to look for chemical signatures in muscovite and determine the microchemistry environments and how they change from zone to zone. I would use elements such as potassium and rubidium to analyze the mica, and there's a lot of trends that reveal themselves to us. So let's go down. All right. So in my sampling, I would go out, I would select a site, and in order for me to have an accessible site, I'd want to go find an area that has a parameter that has mica crystals. I'd go and mark it out and make a latitude and longitudinal grid. So that would be a horizontal x-axis and a vertical y-axis, and we'd measure it out in inches, and we'd make a grid. And so each one of these mica samples have an x and y value. So say I found it 2 inches in this way and 10 inches up, it would be 2, 10. And using that information, along with the potassium-rubidium ratio, I would make a z value. And what we can do with that is visualize the differences in the microchemistry environments, because every pegmatite has an initial amount of elements. And as a pegmatite forms concentrically inwards, it uses up a lot of those elements. And so potassium gets used in a lot of things like mica and feldspar, but as it gets used up, rubidium starts to kind of come in, and rubidium doesn't really form major minerals in the main pegmatite system until later stages. So it kind of tells you a lot about the formation and kind of how much potassium was used, and then it kind of, yeah. So to visualize that, I made some 3D surface plots. So if we go down, here's a picture of one of my sites. So this is site 4. That's located right here in the Emmons Pegmatite quarry. And you can see I kind of have this pink parameter laid out, and we would do X, Y, and then Z would come out this way. So on my next slide, I actually have a picture of my tables. So this is just from site 4 alone, I would take the potassium, but it comes in an oxide, so I'd have to convert potassium oxide into potassium, and then make a ratio over rubidium, and that would be my Z value. And what this tells us, just in this one site alone, site 4, our maximum value is 21 and our minimum is 7.64. So the lower the Z value is, the more evolved chemically the pegmatite would be. And so that in itself is already a lot of diversity for one specific like 40 by 40 inch parameter, which is really interesting. It's all in the footwall of the pegmatite margin. You'd expect it to be pretty homogeneous, but there's a lot of variety, as you can see. So our next slide has a picture of a graph. This is the lined up graph with the fractures that you could see in the earlier picture. So those fractures, they have a lower Z value because the rubidium, there's higher rubidium concentrations, and it's later stage intrusion. So there's a lot of stuff going on, and that's expected because it's more evolved. However, in these zones, on the either sides of the fractures, you would think that it would be pretty homogeneous with the Z value. It would be pretty similar, but as you can see right here, there's a big spike right there, and that is very interesting because we thought that they might be pretty similar in Z values. So that's something to look and think about for future work. But it displays that, yes, this makes sense with the Z value. It's a little bit more evolved, but these are very different, and that's important for our understanding of pegmatites. Here's all of my sites. I did all 6 of these, put them together on an XYZ surface plot, and line it up with my site. And as you can see, there's a lot of differences. So right here, like this is all one zone, but there's all this change, which is like kind of goes against what we think about different zoning in pegmatites. All right. Now, implications. There was, like I said, there was a display of lots of different chemical environments, and there was no zones that had a unique Z value that was uniform throughout the whole area. There's a lot of microchemistry environments that, are a little bit unique, and that's pretty cool to me. And so why is that important? All right. It's important to understand pegmatite. They're a very unique type of rock. They have a lot of resources that our society depends on. And it's important to understand how much we don't understand some things sometimes, so we can kind of open up some more doors to explore pegmatites in general and what it means in the future. So that was my first 6 weeks with Al. I'm submitting an abstract right now to GSA Connects in 2026, coming up in Denver. So I'm going to be hopefully going out there and doing some work with that. And then the next 6 weeks of my internship was with Miles, one of the curators here at the museum. So my task was to go through the James Sawitzki collection. He had about 354 pieces that Carl selected. You can scroll down a little bit. It's a little bit more about my cataloging. So I have all these boxes, and they're marked with a pink sticky note. And I'd take the locality, the species, its history, and the date that it was found, and I'd put it all in a big Excel sheet. And it was cool. I got to learn a lot about new mineral localities that I've never heard of, new mineral species. And it was cool to kind of get a new perspective on like mineral history. It's something that I didn't really ever think about, but when you're holding a card from the late, like early 1900s with all this information about this one specimen, it kind of puts in perspective like how much history and how much work goes into the museum work, having all of its history in one location. So here are some really cool specimens that I got to handle. It's cool vanadinite. This is titanite from Ontario. That's actually going to go in one of the drawers down there. This is a really cool malachite piece from Congo that I thought was really cool. So then I got to work after I finished my 354 specimens that I cataloged. I was able to start making a display. So here was my concept design for Ontario minerals and Mexican minerals. It's kind of split right down here. So over here we have some minerals from Mexico. This is Ontario. I made a little display. If you scroll down, there's a picture of me with my display. You guys can go check it out later. This is what I just showed you guys, and this is all from Quebec, or Ontario too. And along with my internship, I got some fun stuff going on. So I got to go and mine with some cool people, open up some pockets. I played some music here at Suds, which is fun, and I went with my friend Natalie. We went to Bumpus and got some good exploration time in. And then yeah, here's some cool crystals that I got to find while I'm up here. This was from Hayes Ledge. That's from Hayes Ledge. This is from the Havey Quarry. This is from Connecticut, and that's from the Harvard Quarry. So yeah, the outcome. So I learned a lot of problem-solving skills. Got to do some cool research and figure out some things independently, which is really cool. And I got to connect with a lot of people as well and learn a lot about minerals. It's also pretty humbling being in an area where there's so much knowledge. It kind of makes you realize what you can do and like the possibilities of, like, you know, you can kind of be whatever you want if you really put in the work. I'm super grateful that I got to be here for the summer. It's bittersweet. I say goodbye in a week or two, but I'm super happy that I got to experience this. It was a blast, and I learned a whole lot and hope to take this with me in my future. So thank you guys.